MacLean-Fogg.
Since 1976, Metform has been a leading manufacturer in northwestern Illinois, supplying parts and solutions to the automotive and heavy truck industry. Each day, we continue to build a thriving culture of teamwork, innovation, and opportunity. Metform is a division of MacLean-Fogg, a fourth-generation family-owned manufacturing company with a track record of success, stability, and strong family values. We know people are our greatest asset, and a respectful and safe work environment is never compromised.
All right, good afternoon, everyone. I'm Steve Wright. I'm the general manager at Metform, and I think the video just kind of explained that Metform is a division of MacLean-Fogg. John will talk more about that in the next segment. I wanted to talk about the critical objective of this project for us. For those that don't know us, hot forging is core to our business. We have 10 Hatteber hot forming presses, I think the largest fleet in North America. The largest of those machines is an AMP-50, and we only have one of those. We produce parts for Chrysler, ZF, and other major OEMs. We installed the machine in 2012, and we've had 3 kind of major unplanned maintenance events on this machine. That being the only machine we have and being an automotive supply company, you can't have that. And you can imagine the anxiety that created for our customers. We have a good preventive maintenance system in place, I think, but we recognized we needed a better predictive maintenance system. So we partnered with IoTco to use Predictronics. John and Roman will walk you through that in more detail. But for me, I'd say as a general manager, I like what I see so far. We're able to monitor the machine health and see real time how the machine is doing, start to see a signal of a problem before it becomes a major problem. We have a long ways to go in terms of learning how to better utilize the system and gain confidence in the system. But at this point in time, I'm really pleased with the progress we made. And as John knows, I'm anxious to expand this to the other 9 Hattebers. So with that, I'll turn it over to John Delk.
Thank you, Steve. Looking at the slide, we've got showing some of the products that we provide to our customers. On the left, you see some Securex wheel nuts, which go to heavy truck and trailer. You see some gear blanks that we provide to automotive, and then some various special fasteners and special form parts that kind of represents the types of parts that we produce. The processes that we follow are basically our hot forming, followed by heat treat process, and then we do some secondary operations to clean up the parts, and then finally machining before they ship to the customer. But as we discussed, the hot forming process is really the kind of the backbone of our business. And on the next slide, just to give a little bit of context to the process, we're basically taking steel bar, heating it up above the transformation stage to 2,250 degrees Fahrenheit. A blank is cut off. It is then moved to the next station where it is pressed via a punch and die set into a basic form. We add some contour in the second station, and then finally there's a knockout of a hole in the center in the third station. This process is happening at a rate of about 75 to 80 strokes a minute. So the machine is moving pretty fast, and as I highlighted, the parts are pretty hot. So moving on to the next slide, which kind of sets the foundation for our work. At MacLean-Fogg, we developed a digital transformation strategy, and these were some of the key elements that we wanted to have, and they dovetailed very much, as Mo and David described, how we'd set things up. We definitely wanted to define the business need for this project. We had an ROI of less than 2 years. By starting small, we wanted to focus on our most critical asset and just that one asset. And as we were developing this project and where we wanted to go, we set our roadmap for the various areas of the business. And as you'll see in the next slide, that we mapped that out over several years. Some of the key elements in terms of building our roadmap, we recognized there was going to be a cultural change within the business as to how we were looking at maintenance, very well established with our preventative maintenance process, but wanted to take it to the next level to get to predictive maintenance. And so we also recognized the importance of building some partnerships within our team and with our external partners, including IoTco and Predictronics. We learned very early on that it was important to be open, to make sure we were getting good feedback from the team, and then to be flexible with the things that we were learning. Jumping to the next slide, you see just a snip from our roadmap. We really had it organized by the categories of Industry 4.0. Wanted to focus again on where is the benefit to the business. We've got some timelines as to where we wanted to take which steps and ultimately set the destination where we wanted to go in our future state. But if we move on to the next slide, we'll talk a little bit more about the project in particular. Our biggest opportunity was with our AMP50 hot former. Again, most important asset within our business. Setting the baseline, we have a team of seasoned operators and have added some new team members along the way. We have a very strong maintenance team and a very good preventative maintenance program in place. And we've had good relationships with our OEM, Hatteber, the equipment manufacturer, and with our outside support teams that help us when we have challenges. We recognized the need to look at what was our downtime, trying to improve the number of pieces that we can get off of that asset and make sure that we're avoiding critical downtime that would affect our ability to deliver to our customers. We wanted to focus on the drivetrain of the AMP50 since that was probably the area where we saw the biggest opportunity within the asset. Some of the challenges that we met from a data collection standpoint, there's a lot of spreadsheets, a lot of handwritten notes, a lot of tribal knowledge. And so we wanted to make sure that we could gather that information and put it into context as we were analyzing the equipment. And we recognized that there was a gap in the data that we had. We had some good information off of the machine in terms of how it's performing, data that was captured within the PLC, but we needed to make sure that we were providing that data to the right team members at the right time so that the operators were getting information, so that our maintenance team was getting good information, and that our leadership was getting good information on what our next steps might need to be. We recognized that there was a gap in instrumentation. So as a team, we worked together on sensor selection to make sure that we were getting good data from the machine to put the other pieces of data that we had into context for how the machine was performing. So as a team, we decided on 4 collection points around the drivetrain, and we went with 3-axis vibration sensors. So moving on to the next slide, I'll let the PDX team provide a little color of the PDX solution.
Thank you, John. And to give you a little bit more background about the underlying technology that was used for this predictive maintenance use case, we're using the PDX software, which was developed primarily for these Industry 4.0 and smart factory types of applications, including predictive maintenance. So the software has modules for data collection and connectivity, because collecting good quality data is the foundation for making better decisions about your machine health and equipment. And it also includes modules for analyzing all this data. It's a combination of pre-processing techniques, extracting metrics or features from the data, as well as machine learning. And that configuration is then sent to our deploy software, which runs all these calculations, for example, on an on-premise server, and presents the results on a dashboard that you see here. So these are actual screenshots from the deployed solution. And the MacLean-Fogg will show you an example of the health monitoring results for one of their sections of the machine that we're monitoring. So in terms of the architecture for how the solution was configured, we start with the machine layer and we look at what data we can collect, which includes sensors that may be already there for the control of the machine. So this can include using protocols like OPC-UA to collect various tags related to the machine, whether it be tonnage or maybe the stroke rate of the machine and so on. In addition, we looked at adding additional instrumentation to the machine, such as vibration, at various locations. I believe we ended up selecting 4 tri-axis accelerometers to monitor the condition of the machine. In addition, with that in mind, we would use our data collection software to aggregate all this data, send that data to the on-premise server, where the more in-depth analytics could be run, including the machine learning to make sense of all those patterns. And those results can then be displayed on a dashboard, as well as presented to the end user. So I'll hand it over to maybe Roman to give a little bit more specifics about the actual sensor selection and installation, including the vibration sensors that were picked out.
Thank you, David. So as David mentioned, I think kind of one of the biggest aspects to this project was kind of identifying the vibration sensors and what to do with them, where to put them. The actual recommendation came originally from Predictronics, and then with some discussions internally between our team that is both heavily involved with the machine, as long as the machine builder, and then also a partner between Hatteber and ourselves, FES, Forging Equipment Solutions. You know, we've had a couple of discussions on, do we want single axle, triaxial, and positions on where we put them. And honestly, discussions got into the fact of not even general areas, but on which bearing caps, what would be best to, where would be best to put the sensor without possibly causing any kind of additional stress or anything on the machine. So we were very heavily involved with the builders in determining a lot of this information as well. But ultimately, due to some of the failures, as Steve Wright has mentioned, and where some of those failures might have occurred, we have decided that it was best to go with triaxial to get all three ranges of motion for the shafts that we were monitoring. And then they are spread out and touch nearly all the main shafts within the main drivetrain on that machine. And then I will go ahead and kick it over to John. You can kind of talk about our dashboard a little bit.
So the data you see is off of our AMP50. And to put some context to the data, every 20 minutes during a production run, we are gathering 10 seconds worth of data at 10,000 hertz. So there's a lot of data being collected. Our PDX solution is doing some analytics in the background and providing us with a health index. Early in the process, we established a baseline of health with about 3 weeks worth of data. And so what you're seeing is, with all of the different factors, how we are deviating from that baseline of health. And we're very early in our journey, but the things that we're seeing is we're trying to better understand what does the data really mean out on the shop floor. And so the process is really generating a lot of conversations between our maintenance team, our operations team, and Roman and myself. As we see some kind of change in the data, we're asking a lot of, what did you see? Did you see what I just saw? What does it really mean? And as ever important, let's go out and take a look and see if it's showing, what we're seeing in the data is showing up on the shop floor, and what we're seeing on the shop floor is showing up in the data. So we've got a good picture of health over time, and we monitor that on a regular basis. And what you see in the lower part of the contribution plot, as a data point is established, there are various factors that are contributing to that difference from the baseline. And depending on what frequency range it is and which axis and at which point. So we've highlighted you see the 1 point in yellow that's out slightly above our baseline of health. And again, it's an opportunity where we've established some good dialogue of, do we really understand what's going on with the machine, and are there things that we need to do to bring our health back into check closer to that baseline? So jumping onto the next slide, really it's been a good project, and it's been a good learning experience. What we recognized is that we really need to make sure we understand our process well before we start creating that digital twin of the process. So there was a lot of good trial and error back and forth before we established the key things that we needed to do. And as Roman alluded to, our decision on vibration sensors was key to the success. A couple of things that we wanted to make sure that we did, we wanted to use what we already had, whether it was the data that was coming out of our PLC or what was already provided by the piece of equipment. We wanted to work with a partner through PDX that was helping us use what we already had, as opposed to a rip and replace approach. And then we recognized that from an infrastructure standpoint, there were some key areas where the connectivity, we needed to work through some details. And so getting a good assessment of what we could do and what we couldn't do with the infrastructure that we had was important, which led us to how we connected with our IT department, because that piece of keeping our IT and our OT groups connected and working together, understanding each's roles and responsibilities, that has been key. And then the last piece, I think, is really remaining true to our roadmap. There's always a desire for mission creep to want to expand further, faster before we're ready, or to see if we can get more out of what we've already accomplished. We recognize that we really needed to take the time on the front end and understand the data before we started making assumptions on what we saw in the machine health. So with that, I think we're ready to jump into any questions.